So our objectives or goals, we had two objectives. That was to determine a method for separating the components of the pigment, and then to be able to identify those separated components. And then the unknown that we were trying to analyze was a dry powder like pigment that had mordant and dye.
So for results for group A, we found that throughout all the different versions for blue water, it rested on the top layer, which was the cyclohexane layer, and which remained fully separated from the DI water layer and the 1M HCl and 1M NaOH.
So for orange, we found that there was a lot of like mixing. There was some where the bottom layer was lightly tinted and there was where the top layer was lightly tinted. But most of the dye was in the top cyclohexane layer.
For red dye, we found the dye mostly rests on the bottom layer, which changes throughout each. The first one's DI water, the second one's 1M HCl, the third one's 1M NaOH. And it remained mostly clear, except the DI water had a little bit of running, but it was still mostly clear.
And then for the mordant, it usually remained for the first one, it remained in the cyclohexane, it didn't cross with the DI water. And then for HCl, we noticed that it kind of dispersed throughout the solution, so you couldn't really see it. We weren't really sure where it ended up. And then in the NaOH, it seemed to be mostly in the NaOH layer, but there was like a little weird bubble between the two layers.
These are our results, which are pretty similar. For the blue dye, you could probably see the most difference in separation. For the orange dye, it mixed a bit more. For the red dye, we noticed that red was the most vibrant. And for the mordant, it mostly went into the cyclohexane, whatever DI.
So we ended up remaking our flowchart because our original flowchart was not great. I'm going to talk about what we did.
So we had our powdered lake pigment mix. The first step we did is we added 1 milliliter of cyclohexane and 1 milliliter of 1M HCl, and we shook it to mix, like aggressively. That's why not aggressively. Instead, we had our two separate pigments now, so our second step was to separate the bottom red lake pigment into a separate vial using just a pipette. And then the third step was in separating blue, which was just with a pipette as well. And in step 4, we still had our orange dye and our mordant together. So we had to add another 1 milliliter of cyclohexane and 1 milliliter of DI water, and we shook it to mix as well. From here we used the Hirsch funnel to separate the solid mordant from the rest of it. So we had the mordant on the filter paper now, and we just had to separate the orange light pigment step 6 from inside the Hirsch funnel vial, just using a pipette as well, and that sat in the DI water.
For our flowchart, I went with the dilution for the second step, and did the Hirsch funnel process first with all of the dyes together in one vial, and then the mordant was separated onto the washcloths, and then that's how she got the red dye by itself, but then she had to get the blue dye and the orange dye separated, so she just put 1 milliliter of NaOH into the vial, and that's what separated them, so she put them into separate vials.
And this is like completely different from what we first had for our flowchart, because we did plan on doing the filterization last, but I realized it would be easier to see what's separating for the colors, so we did go to this step.
And then here's our implementation results. So when we did step 1, the red dye separated to the bottom layer and the blue dye separated to the top layer as we expected from the previous results. And then in step 2, we separated the red pigment into the other vial, but there was still some blue left over, so we tried to pipette that off as much as we could. And then for step 3, we cleanly separated
step 4, we had the orange pigment separated into the bottom aqueous layer and the DI water. Minimal issues there. The 5th layer is going to be used there. The Hirsch filtration, we had the monomer separated on the filter paper, and the orange pigment was cleanly separated into the beaker. Our 6th step, the orange pigment we did put into a separate vial, but it still had some semblance of blue pigment as well with it.
Okay, for our flowchart creation results, for the first step, the blue and orange dye went to the top layer with the cyclohexane, and the red dye went to the bottom layer with the DI water. The morning went in between the layers. For the second step, the morning separated from the filter paper, and the liquid solutions was a mix of the dye, cyclohexane, and the water. And it stayed in the beaker. The third step, the red dye went with the DI water, and separated into a new vial with a pipette. It had a red-orange tint. The blue and orange dye solution with the cyclohexane was poured into a new vial, and it had a dark turquoise tint. The fourth step, the blue dye went to the top layer with the cyclohexane, and the orange dye went to the bottom layer with the NaOH. And in the fifth step, the blue dye went with the cyclohexane, and the orange dye with the NaOH with separated into their own vials. And some blue dye remained at the top of the orange dye with the NaOH solution because pipetting was a little bit difficult. For the similarities, both of us use cyclohexane and DI water. The blue dye always went to the cyclohexane layer, and some blue pigment remained in the orange dye solution. The differences, we use different aqueous solutions, filtration process at different steps. The group B had a red-orange tint, and the DI water remained in a different color dye.
And then for overall, group B was uncertain if all the dyes were completely separated, and so was group A. We didn't know if using just the pipette was enough to separate the dyes. Both groups were successful. Group A had less orange tint in their other dyes.
So some of our learned concepts, we had how the different aqueous layers will interact with the pigment and cyclohexane, the proper uses of a Hirsch filtration system, and how to differentiate between substances by their characteristics.
The applications can be used to separate other liquids and solids. They identify solutions and substances